All right. Welcome to what day is it? 6th of December. We are diving on Tengosed Seamount as part of the Octopus Odyssey 2 expedition on the Falkor 2 with the Schmidt Ocean Institute. My name is Beth Orcutt, one of the co-chief scientists of this expedition. We are studying how fluids move beneath the seafloor between outcrops in this area in the Pacific Ocean offshore Costa Rica. This seamount here is one of the largest seamounts we're going to be diving on today's expedition. And when we were here a few months ago in June 2023, we discovered a small hydrothermal spring on this seamount, which is something that was predicted to happen, but had not been documented before. So we were really excited about that. And we're coming back to that site today to recover some experiments and collect some new samples. And it is breakfast time, according to my alarm. I'm going to pause here and ask a question of my colleague, Beatriz Naranjo. Are any of these the corals that Randy would want?
Yeah.
Okay.
The white ones.
Yeah?
And probably that one. I will
May
have to take
I use the camera?
Go ahead.
So,
Yeah, and also there are some coral suit for Wendy.
okay, great.
Those, they look like,
Yeah? Perfect.
and this one is, I think it's sweet, yeah.
Yeah. Oh, yeah?
Red. I think so.
Okay.
Yeah.
Oh,
There's
I would have
other,
said.
but this one is also for
Oh,
Randy.
Yeah. Okay, we'll take note of that to collect them after we're done with our ops.
Oh, okay, so you don't do it yet.
No, not just this second. Sorry for that. So what we're doing right now, to our pilot team, we are right in an area that I think we're supposed to be at, this crater feature. I want to come off bottom a little bit and look around for this hole in the ground with a marker next to it.
Okay. And that's where that waypoint should be.
It's where that waypoint should be. Let's hope.
After that, we're going there now.
And we'll just keep in mind that just to the northeast of that are the corals we want.
That's an interesting topography there, isn't it? It's almost like a little...
Yeah, so this seamount is really not what we were expecting, that we have this carbonate, bright white sediment underneath a really crusty ledge that's almost like a sheet over here. And we would have thought it was like a sheet flow, but when we sampled it before, it's actually just a crust around sediment.
So do you guys have a guess of how that could have come to be? Or?
We are actively exploring hypotheses. The weird thing is that the sediment underneath is really old. It's like 15 million years old. So we're not quite sure why we don't have modern sediments here, how this crust is forming, what's going on.
This is all that old.
We haven't dated this material, but using Maria Isabel Sandoval, who's with us, did some microscopy and could see that the fossils in the sediment were that old, and that we don't have modern fossils in the sediments. Okay, so yeah, let's pop up and maybe just pivot around and see. It should be near that crater feature.
Sure.
Which way are we?
We're not facing
Yeah.
northwest.
Okay.
And I'm just going to start kind of pivoting around and seeing what I can see.
Yeah. It should be one of those collapses. There's a picture of it in the dive plan somewhere. I at least remembered that.
Probably another cliff over here.
Yeah. So it might be in that hole, it might be in this one.
Sure. Oh yeah, I'm facing back towards the north now, so that's probably not where it came from. All right, so I'm going to spin around the other way.
So So that's what we were looking at when we landed.
Yeah.
But it might be over to the starboard side, so
Sure.
somewhere in this area. We're close.
What's that? Yeah, we were just there though. We didn't see it, so we're kind of looking around.
Yeah, I think that's it. That's marker X right there.
Ah.
So this is going to be awkward to sit in. There's only, as you get up to it, you're going to see there's only one spot to sit in.
But we're gonna sit in that.
Yeah, the marker. So as you're coming around, you're going to see that there's like a blue hole down in the bottom. And this little sandy patch is usually where we sit to sample that hole.
Ooh, okay. I do see that. Interesting. Okay. The only thing we're gonna have to really watch out for is that M3 sonar as we go in there.
Do we have a camera view on that?
We do.
Okay.
That's that one.
Okay.
All right. So you say if I kind of swing around to the right, is that kind of where people normally go, or?
Let me zoom in real quick.
Looks like you might have most of the room if I go that way.
Yeah, that seems about right. We were kind of, this is, you can see exactly the view in terms of the layout of that anemone versus the marker.
Oh, yeah.
So we were kind of coming in like this almost.
Okay.
But
Anemone's to the
however,
left.
yeah, however you think you can get in there.
Okay. Sure.
Hey, dude. You can see some shadow of fish right above us.
And you want the lawn down in that hole there, huh?
Yeah, so what we're going to be doing, the marker is attached to a temperature logger. So the very first thing we're going to do is pick that up and put it in the basket.
Okay.
And then we're going to try to use the high temperature probe to reach as far as we can to make a measurement. And then we'll do the same with the dissolved oxygen probe.
If it's all right with you, I think I'm going to try to land on the top of this and see if we can reach first.
Okay.
If we have any issues, I'll go sit down in there, just because that'll protect the M3 really well, you know.
Yeah, set up how you think makes the most sense.
Okay.
John, could I get the
Absolutely.
whatever view that is? Hopefully my arm movement makes sense.
I'm gonna keep an eye on that aft cam there, will you? How's that? I'm gonna keep an eye on that aft cam.
We also need to keep an eye on the heat flow probe.
Okay.
Make sure we're not smashing into anything.
Touching down, nice and gentle. A little bit of down thrust on. All right, I think I'm steady.
Okay. Can I use the camera?
Yeah, feel free.
Okay.
Yeah.
Sure.
Yeah, let me know if you see anything rocky back there, especially.
Frame grab, you can just click it and then click it
Okay.
and then it'll pull it. You want to type 3, 4, 10, so info here
Okay.
if you want. And then we're going to recover.
No pressure, but whatever you do, don't drop it down.
Where's the 341 comes up?
Just the frame grab.
I need to frame that.
Yeah. Sure.
Okay, and I can track it anything.
Yep.
Okay.
That's fine. That's a business.
Okay, let me grab my glasses.
Okay.
Are you happy for us to grab this probe?
I'm going to do a couple zooms real quick.
Sure.
Just to confirm that we actually see some.
I can actually.
I can see the venting. No, that's fine. I don't want to.
But it's really close because we had to stretch.
I can see some venting there. The camera seems to like come up on its own.
It's because when you're at the limits.
Yeah, okay.
So I'd have to back up. a little
Okay,
bit,
that's fine.
which
This
I
is fine.
totally can if you want.
No, no, no. I don't want to give ourselves any more.
I don't see that, that's all.
Oh, okay, thank you. Yeah, can you just take a frame grab of the marker X shimmering is all we need to say.
Yeah, rack in, but then it's gonna then the portrait will walk it. Probably try it.
You want to rack in? Okay.
Just see if that gives you a little. See
Yeah, it's okay. This is fine.
Okay.
Okay, so the very first thing we want to do is grab onto that marker and pick it up, and we're going to stow it in the milk crate with on the starboard or the port side.
Okay. Roger that.
Oh, we didn't bring the camera down today, or the light pack. Okay.
No, it's not working. So what we did
Okay.
instead is we out this right here.
On the arm.
Yeah.
Okay, great. I'll make note of that.
Temperature logger's going where?
Temperature logger's going to go in the port milk crate.
So yeah, you do have a bonus milk crate today.
Okay, great. Now BBC light. So I'm gonna, for this part, yeah, you've done this, so we'll actually get big enough to walk it when we collect it as a sample. So Chris already got that training.
Okay, good.
Yeah,
You wanna sit here?
No, you can sit here. I got it.
Okay.
Just take this.
Yeah.
And a pencil. Because
Oh.
you never know.
Starting to brush the heat probe a little bit. Starting to brush the temp probe a little bit. You might trying to go to the right, come down,
Yeah.
go to the left. You know what I mean? Yeah. See it?
Oh yeah, it does stick out kind of far, doesn't it?
A little more to the right, 'cause you're kind of pushing down on that middle now. You know what I mean?
Is it possible to reposition the high temp probe and push it further over?
See that right there? That's what you gotta watch out for. I think you can just go down under it and then go.
Oh,
over.
okay.
And that's way down in there, huh?
Yeah, it's really deep.
You can try the port arm too if it's. I can hop over that way a little more too. Yeah, I think I'm gonna have to. Alright, you ready?
Yeah, I think we're gonna have to hop up. Yeah.
Can you hop left a little? See what that does for you. Alright, go for it.
Is that when you're flying, you because we're so close to the rocks, can we make sure that you have a view of the heat flow probe also?
Oh, yeah, I do.
Oh, you do? Okay, wonderful. I didn't see it down here. I forgot it's up there.
What's that? Yeah, beautiful. You're close, you're touching it. I think any way you can grab that thing is fine. You can grab the X marker. No, just go away. Because I'm kind of having to hold it. It's teetering on the rock, you know?
Hey. Oh, okay.
That's good. You can just grab the block. The white block.
Yeah,
Yeah.
that's fine.
Get it. Yeah, there you go. Okay.
So it's a marker, a dive weight, and then a temperature logger. So it's kind of a long string, and we just need to pick the whole thing up.
That's no problem. Okay, and you want this in this basket on the far left, right?
Correct. Yeah, we're just gonna shove it in there, and hopefully we might have to like twirl it up a little bit so that that marker doesn't float out too much and be annoying. I guess we could also chuck it in the front bin.
Yeah, doesn't matter to me.
Yeah, let's put it in the front starboard,
You put it in the front starboard?
just so we don't have to worry about the float getting caught when we
Portion around.
porch in and out. Yeah.
That's perfect. Spin it as much as you need to get it up. Whenever you're happy, I'll try and porch out a little. Okay. Porching out. If this thing does float everywhere, would it be possible to put it in a bio box where we can close the lid on it?
Unfortunately, that's not ideal because we need all the bio boxes for biological samples. So we've tried not to cross-contaminate.
Okay. No worries.
If we have to, we will, but we try to avoid it. Jeff, do you want to go get breakfast and then you can come down and do the high T and the DO measurements?
Okay.
Okay.
You're gonna do that right
Once he gets this stowed, then we'll start doing the high T, trying to do high T measurements and trying to do dissolved oxygen measurements.
Okay.
And then we'll deploy your sampler. So if you want to get breakfast, and then you can relieve me and I'll get breakfast.
Okay.
Yeah, it's like, just like writing over time.
So you can roll it up more if you need to. Sir? So you can feel free to roll it up more if you need to. just keep on rolling. You almost there? Okay, you can try letting it go through the does. We might have to try and jam it in the handle or something else if it floats too much. Yep. Yeah, let me see, maybe I can jam it in somewhere. You think you might be able to grab it and stick it in that hole where that handle is? Right here? Like that? Just kind of get it stuck in there? Yeah.
Ah, much better.
Yeah, it's just set up for mid-water.
I wonder if you grab it with the port minute to shove it in there
Yeah,
while he's
do
holding
it.
it like that, because once he lets it go, it's gonna float right back up.
Yeah, let me grab it.
And that way he's not trying to scratch his armpit, essentially.
Okay, got it. Is there?
You want me to take it from you and try to?
Go ahead and just get yourself safe.
I'll follow you where the camera's at.
Okay, thank you.
Yeah. Just hold it down with a big weight.
I don't really think we're gonna be able to do anything. I think it's just gonna float, you know? We'll spend all morning doing this. So we'll just go for it.
And shove the T handle through the little loop that it has on the bottom of the boat.
Yeah, might be able to do that. T-handle's kind of big now, though. What's up?
How's this going?
Yeah, you know, rope fun. Yeah, so trying to figure out how to get that in the basket so the float's not in the way. I'm gonna try to stick the T-handle through the loop of the marker, see if that works. Yeah, and then high T probes on the front, your DO probes on the port side front. So we'll just try to reach as best we can down into that hole. And Rue's behind you to help take notes. So just let him know what you want to log.
Okay.
And I'll hop back down here.
Okay.
Try this real quick.
All right, I'm going to hand you off to Jeff.
Okay. Hi, Jeff.
Hello.
Oh yeah, remember that you're live air.
Okay.
Got an audience watching us who would love to hear what your thoughts about the geology of this place.
Ah,
I
yes.
see their comments up there, if you'd like. But yeah, more just a reminder that there's a live mic.
Got it. Thank you.
I'll see if I move this stuff. Carl, the other thing's gonna come down, so you have to grab the float, bring it down. Yeah, you have to grab the float, because if I move this up, the float's gonna move up, so I'm never be able to put it through the loop, you know what I mean? You can grab the rope right below there too, as well. Something you can pull down with. That's it. Right down. Fellas, we got long floating rope. I'll make it less so.
That's funny. Please not through there.
Yeah. Got a pretty loose grab too. Everything's so floppy. Yeah, pushing spaghetti. Yeah.
Oh, nice.
Don't fall out, don't fall out, don't fall out. Alright, I'm gonna let go. Whew. Alright, so you should be able to drop that now. And not float over. Whew.
Very cool.
Nice.
Good idea, Carl. Okay.
Ah, very nice.
I didn't see that one.
What's next, Jeff?
Next thing is we're going to grab the temperature probe, and there's a hole right down in front of the basket. We're going to reach down as far as we can
Okay.
and try to measure temperature down there. And then we're going to try the dissolved oxygen. See, sort of right in the middle. There's a hole right there.
Okay.
And we'll just see how far we can get the probe in there, and then we'll try the same thing with the oxygen probe with the port manipulator.
So if you portion it in, you'll be able to see it better. You're basically like, like if this is the edge of the hole right here, you're basically balanced like this right now. Just so you know. See this? Basically, like the front half of your ROV's not even, there's nothing underneath. Kind of on that cliff. Alright, buddy.
So sorry, I didn't hear. What were we doing there?
Yeah, we're gonna do a temperature probe.
Okay, our temp?
Yep,
Okay.
into that hole. Yeah.
Yeah, that was fun.
Good way to start.
Alright, felt good?
Yeah.
Cheers.
It's not too horrible there. Let's see what we're doing. So just straight down in the hole there.
Yeah, straight down as deep as you can go.
Okay. So I'm just gonna stretch it out a little bit. So it's come out almost all around. Like further down. So if you switch to stethoscope, where it's at? There you go. 2.05. .9, 2.34.
Does it look like it's coming up like on the left side of the edge more? Like the flow, or is that just my eyes?
I can move it around.
Okay.
See if we can find some. Let's try. Two.
So we're getting temperature readings of about
2.2 is the highest.
2.2 degrees Celsius.
I'll come over to the left right anyway.
So yeah.
There, so I'll stretch it.
Reduce 2.2.
Yep.
Okay.
Yeah, it's not changing too much. Smallest there.
Maybe can you reach further away from us too, or is that no? Okay, that's about it. Huh?
Yeah, it's
Okay.
maybe
All right.
Right about there is probably where I would go.
All right. Yeah. One.
2, yeah.
Yep. Compared to 1.9 as the background. All right. Let's try the dissolved oxygen one.
Do you want to just, if I just keep this in my hand, we might use it again then?
No, after this we're gonna take out the milk crate
Okay.
and then lower the intake down the hole.
Can you orient me here? What's the hole we're trying
That's
to
the
get into?
hole. Yeah.
Okay.
So, oh, we're gonna take your samples here, right?
Mm-hmm. We're gonna try.
Yeah.
Have you been able to get a temperature yet?
2.2.
You're in it. Yeah, that one was pretty good actually, I think.
I'm gonna go eat.
Okay.
Yeah. The other one, I didn't try it, but I was. Alright, so
Oxygen's on the port side.
I just forgot to put the
Yeah.
yeah.
Oh, on the.
No, yeah, I mean, I made the observation, but I just have to add that one up there.
Oh.
Yes.
do us a favor, just so you can see, I want you to watch that and come down. Actually, you should see it.
I was too,
Just keep an eye on it.
I wasn't awake.
For the light cable. I think I've got a nice good.
Oh, alright. I'm gonna take the camera.
Okay.
Up at the
See
L.
it. Keep watching
there.
the sit cam. If you're watching the sit cam, I'll watch the.
Yeah.
Just tell me all stuff. If it looks like it's. Nice.
Porch back, we can use the signs for color.
Oh yeah, there's lots of it there.
I'm not seeing any data from your oxygen read just yet.
I think actually, if you porch out, I'll just watch your sit cam.
There you go. Scratch there.
Would look like it's getting too tight.
So right now we have the oxygen temperature probe out there that's trying to see what the oxygen and temperature is of the water coming out.
Still not getting any data from your oxygen.
No data or no change?
No data.
Do we need a power cycle?
There's some in. Go.
It is, but it's wired into a 12-volt channel, so we've got the button on the camera page. It's a little wonky. It is channel 3, but that won't control it. Yeah, we had to swap some. Yeah, you don't need that on. But it knocked out. I don't think you need one. We didn't have one. Just fire it on just for a second. Just to verify it's not doing anything.
Looks good. Give you this until we get anything better.
Oh, good.
These are the last ones coming.
Okay.
Did you just get it now?
Yeah.
You didn't when you turn that button on?
No, I think you
Okay, so yeah, we don't need that.
Yeah, so we're extended about as far as we can go. Looks like we're sort of above the hole. Mostly getting background measurements.
I don't think I go much lower than that.
Okay.
That cable.
Maybe if you could like move it to the lower left, they seem to get a little more, or like over the hole, but to the left side. I don't know if that's too far. Or...
Wanna go there?
Yeah, I'm sorry, like right there.
Right side?
Yeah. Or sorry, yeah, the other left. Yeah.
I got you.
Up there now. On that screen.
Yeah. Oh,
Right there.
okay. Thank you.
No worries.
If I can see it, if you want to tell me what the values are.
Yeah, so the oxygen's on the left, it's 92.
92.
Yeah. Temperature's on the right, so that's 2.35.
Put the same screen up for you there.
Oh, awesome. Thanks so much.
Yeah, I'd say just maybe try one more spot. I can't imagine it's going to get much higher just because I think we don't have the reach.
What was the highest you saw? I can't quite read the numbers there.
We've got, let's see, temperature now is almost 2.4, and oxygen's down to 92.3,
Right.
92.2. Well,
Still fine.
It takes a while for it to.
yeah, so it's pretty. The oxygen is pretty much leveling out at 92.2, and temperature's just slowly warming up 2.4, but it's not jumping. All right, well, why don't we pull that back, and then the next thing we're going to do is the milk crate has some osmosamplers in it,
Yeah.
and it's got the tether at the bottom of it. At the intake, there's a dive weight and a temperature logger in the intake, and I think and a little floaty. But I think we can just get over the hole and just try dropping it down the hole.
Because when I pulled it out, it's got the tube that goes to the T handle with the little sensor on it. Did you want me to? I could drape that over the ROV and then pick up the whole basket and lower that as far into the hole as I can, because we'll have to recover it too, right? We'll
Yeah.
Drop it super far down. But if we can get the sensor as far into the hole,
Yep.
like just kind of dangle it and then just set the milk crate somewhere where we can reach it next time.
That sounds wonderful.
Okay.
Yeah, the temperature got up to 2.45, and now it's cooling down, and the oxygen got below 92, and now it's coming back up.
Oh, and yeah, the other one, so we can see all the way down. Looks like it's working right down there. Yeah, probably. Just, good view there. Cheers.
Yeah, so the W donut,
Yeah, the little weight
Yep.
wheel there.
yep,
And then, yeah, so.
that goes, yep.
So if I can get that, what I'll do is I'll drop it over the front of the porch and try to, we'll try to stretch it out and get all the tubing out.
Yep.
Drop it down, and then we'll pick up the basket, let it hang, and try to get it as far over the hole, and then find a place to gently set the basket. That way we can get it next time. We
Yeah.
don't need to get it back.
Yeah,
Okay.
yeah. So right now we're getting out the basket in the front. It's got a couple of fast flow osmosamplers, which are continuous fluid samplers, and at the intake there's also a temperature logger, so we'll have a temperature record to go with the fluid data.
Yeah, what I'll do is I'll grab it and lift, and once I get it clear, then yeah, I'll bring the porch in, and then we should be able to just find a small to sit there, so we'll go here.
So these osmosamplers will be able to pull in about a mil an hour of sample continuously. The O2 here was a little lower, not much. It was basically 92 or 93 for background and 92 for the water that's was measured. But we were kind of above the hole, so hopefully this will be better. Yeah, there you go. That looks wonderful. You do a frame grab?
Yeah, what we've done in the past too is, you know, that so it'll come out.
Ah, very nice.
Let's try it. It's kind of seeing, I think it's even further. I'll tell you what. If you have faith in us,
Yep.
put it where we first set it, and we'll make a tool that we can use as a hook.
Oh,
to
yeah.
grab it.
Yeah, no
Okay.
problem. Yeah, whatever you feel comfortable with. Yeah.
Whatever you feel comfortable with.
Yeah, you should see what I'm comfortable with. Yeah.
I'm pretty
Yeah.
sure if
Yeah.
we had like a little hook
Yeah.
or something, we honestly it's like 6 more inches down. So
Yeah.
is it gonna fold inwards this way? So yeah. It's,
He's gonna slope. Yeah.
You know what?
You can
I
grab
bet you
that.
we can grab that.
Yeah.
Okay.
Yeah.
It's in.
Yeah. No, wonderful. That looks great. Okay, so the next thing on the agenda is to try to get the water sampler intake down there and do some water sampling.
Okay. Like the Supra.
Yeah.
Okay.
And I will run upstairs and get Julie,
Okay.
and I'll be right back.
Yeah, you can
No, it was very good. Okay, I'll run and grab her.
Do you want to grab? So this one is on 2 things. It's on the bullet light, and then if you go to science, it's on M3 conflict. What's in there?
That went quick.
Yeah.
And so it looked like the DO dropped even though you weren't even that far down.
Just a little bit. Yeah. So.
Oy.
Try.
Okay. Dun dun dun.
Yeah. But definitely get further down the hole.
correlates with temperature. These original learners. I said I don't think so. But
I would say no. I mean, on Dorado, yes, at an individual site. I don't see any reason why it would work.
yeah, that's what I said.
Just gonna try to go like that.
How's your road situation?
Oh no, we haven't powered enough yet, so we'll do that.
Andy's about.
Yeah. Basically, probably just turn the power on to see if anything wrong happens.
We already did that.
We did that?
It faulted.
They faulted. Okay.
Hard? Like, couldn't even talk to it?
Oh, well, we didn't try to talk to it.
Oh,
We just
okay.
turned the power on.
Okay.
Faulted.
Okay. I see.
When you guys have a chance, I'll take comms to Super.
Oh, that, it's, up now.
Thank you. So you got
That'd be okay.
2.24, and
Yeah.
that's what was 90 to make
Yeah.
I'm writing this down.
Well,
We're saving the data.
that's also just ambient temperature, isn't it?
Yeah, it's literally 2.23 versus 2.24 on the
Exactly.
sensor.
Yeah.
Okay.
And 92 versus 93.
Perfect. That's great.
But it says oxygen's 112 here.
Yeah, the sensor.
Yeah, we'll get further down there.
Oh.
I'm not gonna
I
have
thought you were seeing a bigger departure.
No.
Wouldn't be the first issue.
Alright.
I'll just, I'll get all this stuff out. Yeah.
Thank you.
And then we'll, yeah.
Jeff, can you do me a favor?
Yep.
Alright.
On the whiteboard and on the wall by the ROV office
Yep.
is the schedule of who's on shift.
Yep.
Can you bring that in here?
Yep.
I'm here.
Yep.
Yeah.
Just in case.
I wanted to put it up here.
Oh, yeah.
Just, I think it's caught on that weight, but I think it's
Yeah.
gonna- should take one.
No, I got some. Access to the stuff.
Yeah. Seaport's over there?
Coming on later.
Someone just sent me the weather.
Thank you very much.
Okay. You're gonna have to reach down.
It's snowing back home. That stuff's going.
Yeah.
You look over at it.
What I'll do is I'll come this way. This side.
Okay, Maria, you wanna come up here? Yeah, so that's the super. So we've already done all this. So now we're setting up for Julie to sample. So we're, it's gonna go, yeah, hopefully we'll see the hole. Can't see it with this view. And we'll sample as long as we can. On the schedule it says 3 hours. We may need to adjust that because we have logline fishing pressure around us that we may need to move for. So there's not going to be much happening with the pilots. Julie will be talking them through. So feel free to say whatever you like.
Okay, I would.
Yeah, and once they get set up, it's probably just
Bye.
once Julie's fine with where the sampler is, then if you want to move the camera around, just talk to the pilots about it.
Yeah.
Yeah. Okay.
See what that takes us first.
Good morning.
Good morning. Good morning.
Good luck, Julie.
Thank you.
Hello.
This is Maria from University of Costa Rica, from the Central American Geological School, and we are here again at Tengosed, Seamount. So I will be with you this hour. I will principally speaking in Spanish, so if you have any question in English, just let me know. I will try to get an answer for you. Muy buenos días a todos y a todas. Les habla María Isabel Sandoval de la Universidad de Costa Rica, de la Escuela Centroamericana de Geología. Estamos acá hoy transmitiendo desde el monte submarino Tengosed y estaré acá con ustedes a esta hora contándole un poco de detalles de lo que estamos haciendo acá y hablando principalmente esta hora en español. Así que hagan sus preguntas en el chat y trataremos de responderlas. En este momento lo que se está realizando es se va a poner este equipo para tomar muestras de agua para estudiar los microbios dentro del agua. Acá en este sitio ya lo habíamos visitado hace 5 meses en la expedición de junio y descubrimos este pequeño hueco o conducto. En esta vista no se aprecia, pero ahorita lo vamos a ver un poquito de detalle. Por el momento estamos tratando de colocar este equipo dentro del hoyo. Tengosed es el monte submarino, el cual está cercano al Dorado, al sitio donde se encuentran los pulpos que hemos estado viendo durante esta expedición y el sitio de estudio más de detalle. Y también este sitio de Tengosed se han realizado bastantes estudios de detalle a lo largo de diferentes campañas de exploración desde el 2008, 2013 actualmente, y ahora en junio que vinimos y ahorita en diciembre. Entonces hemos estado midiendo cambios de temperatura, tomas de agua, etcétera. Este sitio es particular ya que se encuentra esta caída de rocas. Esto le llamamos un colapso. Y lo que hay es en la base tenemos unas rocas blanquecinas que observan ahí en pantalla, formadas por organismos pelágicos o plancton que se van acumulando a lo largo del tiempo, millones de años. Y este material se ve bastante disuelto en algunos sectores. Por ejemplo, acá que sale un conducto de agua supuestamente un poquito más caliente. Eso es lo que vamos a tratar de medir, si por aquí hay una salida de agua. Aquí se observa un poco el hueco, el conducto. Aquí lo estamos observando. Y estos materiales blanquecinos lo que generan es se van diluyendo y son más suaves, por decirlo de alguna manera, que estas rocas negras que estamos viendo por encima, que serían un tipo de lutitas o rocas sedimentarias más duras, formadas de lodo compactado. Y estas rocas entonces están encima de estas blancas y colapsan. Al haber un colapso, entonces se forman estos grandes bloques en la caída, que es lo que observamos en este sector.
Are we trying to get it lower?
I don't have much more on this. That's about. I can come like sideways, left a little. I can go to the right a little bit,
Okay.
or kind of inboard, but I don't know if you'll get much more than that. The problem is we're going to be starting to bottom out right here. So I
Can we try that to the right?
yeah, I can go to the right just a little bit.
Right.
Aquí estamos tratando de posicionar este aparato que va a tomar las muestras de agua. Estas muestras de agua se toman durante 3 horas. Es un muestreador muy preciso que lleva muestras de agua filtradas en botellas para sus posteriores estudios microbiológicos. Este trabajo lo lleva a cargo, ya les digo el nombre de la científica, Julie Hoover, del Woods Hole Oceanographic Institute, o le llamamos HOI, y Julie y Amanda Sutherland, también del mismo instituto, llevan a cabo estos experimentos.
Right, they aren't shouldered all the way down.
Yeah, we're like on the limits.
Y como les comentaba, en este sector, entonces en este conducto que están viendo, es probable que haya salida de agua. En Tengosed generalmente es un sitio, es un monte submarino donde hay entrada de agua, y puede haber algunos sectores donde hay pequeñas salidas de agua con un cambio de temperatura tal vez mínimo, pero esto es lo que se desea registrar porque esto indicaría que hay salidas de agua un poquito más calientes también. Les recuerdo el sistema que hemos notado acá, es que en los montes submarinos más grandes, como este que estamos hoy, Tengosed, que es el más grande de todas las estructuras que hemos visitado a lo largo de este sistema hidrotermal de baja temperatura. Entonces el agua ingresa por ejemplo por Tengosed, por las fracturas entre las rocas que hay en el monte submarino. Ingresa agua fría del fondo oceánico, del mar, pues ingresa hacia la corteza, agarra el calor de la corteza por las diferencias de gradiente o cambios de temperatura, y se da salida en montes más pequeños, como por ejemplo Tengosed. Y aquí tenemos la salida. También puede haber en Tengosed algunas pequeñas salidas de agua un poquito más calientes, pero pequeñas diferencias es lo que se han notado.
Yeah, we were kind of basically, we came from the other side, but this is where we got our highest temperatures. I think 2.34 was the max we saw.
Aquí estamos viendo en pantalla principalmente algunos octocorales pegados a las rocas, como ven acá, y también unos corales negros hacia la derecha. También vemos como un tipo de anémona. Y a la izquierda también vemos otra anémona un poco más grande.
What if we just moved over a foot? Would that help us? I don't know what's to the right of us. There could be like a giant rock.
I'm not sure you gain much, but we can try. I think that when Zach came in to land, he tried to land in the lowest impression.
Okay.
Because it's quite a rubble field around here.
Okay.
I remember being here last time.
Okay.
And because last time we were trying to swing that T handle into there, and this is kind of how we set up as well.
Okay.
Just here, show you like to the right of us is. Yeah, I guess you can't see it here, but it's
Another big rock.
rubble field, yeah.
Oh, I hate being indecisive, but I'm indecisive.
Do you want me just to move it around in this position to see if we can find something? What are you seeing exactly right now?
I mean, it's, you know,
Nothing.
nothing. 0.6, 1.
Okay.
So yesterday I was able to get good 2, 3, 4.
Los investigadores a cargo de estas tomas de muestras, como les comenté, trabaja el microbioma de estos fluidos y de las rocas también de estos montes submarinos. Lo que sucede acá es que hay reacciones entre el cambio, el intercambio que hay entre roca y agua en el monte submarino, que crea pues componentes químicos, ¿verdad? Y fluidos, componentes distintos, por ejemplo los microbios pueden variar también, los compuestos en general, y esto se puede entonces asociar, por ejemplo, con la dieta en el caso de los pulpos, ¿verdad? O en el caso de algunos organismos como estos que están viviendo acá, aquí atados al sustrato. Entonces todos estos cambios son los que se estudian en el agua, y ese microbioma que hay en el agua, o el microbioma que hay a veces en las rocas, ¿verdad? Acá generalmente vamos a tomar también muestras de roca, muestras de agua, como las que vamos a intentar tomar acá. Y esto es lo que se intenta pues descifrar con estos estudios, que es ese cambio en el microbioma en estos sitios tan especiales. Les recuerdo que este sitio, el Tengosed y el Dorado, se visitaron en campañas de exploración profunda en Costa Rica en el 2013. Se iniciaron la visita a estos sitios, y fue donde se observaron que en el Dorado habían comunidades, o fue la primera observación de grandes comunidades de pulpo asociadas a estos montes submarinos. Y pues esta expedición que se llama la Odisea del Pulpo, o Octopus Odyssey en inglés, pues ya se viene con un objetivo más no tan geológico o no tan geofísico como se vino en el 2013, sino se viene ya específicamente a estudiar en las comunidades de organismos, las comunidades del microbioma, como les cuento, también la parte geológica más a detalle, y la parte biológica, pues el muestreo, y es lo que hemos estado viendo en estos días. Aquí estamos viendo un poco más detalle del brazo y algunas de las cajas donde se colocan los especímenes o rocas que se colectan.
Seen any difference there? Just move the timer where that other temperature probe was.
Yeah, I'm gonna give it a minute to catch up. Yeah, if that doesn't think there's any other good hole. Yeah, that's definitely closer to it. Alright, so that's like pump off.
Aquí la temperatura que estamos registrando es 2,24 grados centígrados, y la experta está decidiendo si empieza la toma de aguas.
We were talking about if we could, hold the T with one and then hold the cable with the other arm, and then fly up and let go with the T, but still be holding the cable, just to see if we can get any closer, rather than a full drop.
Yeah, I can try that.
But I'm gonna let this settle out.
Aquí estamos tratando de ingresar un poco más adentro de este conducto, así que los pilotos intentarán una maniobra. Los pilotos a cargo, acá tengo dos al lado mío, y un asistente de multimedia, que es el que está tomando también datos de imágenes y de video. También tenemos a la experta Julie Hover, que es la que está dirigiendo el muestreo del super sampler o el muestreo a detalle. Y también tenemos a el que anota todo lo que es lo que se muestrea, que se llama Ryo Akiba, de la Universidad de California de Santa Cruz, que está tomando los datos. Y yo contándoles un poco de detalles de este sector. Les cuento que en Tengosed fue donde encontramos ahora vamos a estar por allá un poco en la tarde, que encontramos una gran cantidad, una gran acumulación de huevos de raya. Así que es un sitio que vamos a volver, es un sitio bastante particular acá también. Es el monte submarino más alto que tenemos acá, más alto y más grande. Como les comentaba, tiene una superficie regular, un poco circular. Ahora tal vez los pongan el modelo 3D en pantalla para que estén atentos y atentas a cómo es la estructura. Y en la superficie es bastante plana. Y afloran o se encuentran rocas, como les dije, en la base, posiblemente lo que son los lavas, los basaltos, que vienen, que se originaron hace bastantes millones de años, unos 23 millones de años en la dorsal del Pacífico. Y encima se depositan rocas o sedimentos que se van acumulando, se van compactando, que son esos que vemos en pantalla. Son estos sedimentos blanquecinos que forman por acumulación de organismos que viven en la columna de agua. Por ejemplo, organismos como el plancton, como diatomeas, como foraminíferos, radiolarios, entre otros, y se van acumulando por millones de años, se compactan. Y también tenemos algunos eventos acá, como estas rocas más negras, más oscuras que vemos en pantalla, que son algunas rocas que tienen mucho más minerales comparado a las blanquecinas. Entonces eso es lo que está cubriendo el monte submarino, o eso es lo que estaría, digamos, en la cima del monte submarino. Estas rocas se han estudiado, primero estudios preliminares que hemos realizado, y poseen principalmente unos entre 15 a 17 millones de años de edad. Como detalles generales, cuento que también el monte Tengosed, o todo este sistema que está a unos 160 kilómetros de la costa al frente de Nicoya, y es este sistema que está ubicado acá. En este momento vamos a ver la profundidad, 2025 metros de profundidad desde la superficie. Este es el monte más alto, como les dije. Generalmente vamos a estar moviéndonos en otros sectores que son más pequeños también durante otros buceos, y vamos a tener profundidades que llegan hasta 3.000 metros, pero al ser el más alto, esta es una montaña submarina real, digamos, tiene una altitud de más de 1.000 metros. A eso ya se clasifica según la nomenclatura internacional como un monte submarino. Un saludo de buenos días a mi madre que está ahí conectada.
Zoom yourself out, leave. Come out, yeah. So I'll just come out, okay. And I'm gonna. I'll try to drag it. See if it works out.
Yes. Le envían saludos aquí desde el cuarto de control, mami.
We're gonna try to tangle it in the hole because we can't quite get down.
La idea es llegar a medir o a tomar muestras de agua lo más profundo en el hueco este, en este conducto. Así que estaremos en pantalla prácticamente en estas tomas durante varios tiempos. Ya cuando se instale el muestreador en una buena posición, pues entonces sí ya podemos conocer un poquito como el área circundante sin movernos mucho.
Let's try this real quick, but if that doesn't work, because that's right, we just go like this and hold the circle on it.
Yeah, you just guide it more than anything.
Yeah. Well, worst case, let's try this first, we're already here, but we'll see how far we can get it.
No update on the fish lines yet?
There's a lot of phone calls happening.
Do you have a quick second?
Les comento que 36% del territorio marítimo de Costa Rica está por debajo de los 3.000 metros. Así que es bastante lo que tenemos. El 92% del territorio nacional, recordemos que es el océano, y principalmente estamos en este océano, pues en su mayoría está en la placa del coco. La mayoría del territorio nacional, así que estamos ubicados acá desde la placa del coco, una placa bastante interesante, ¿verdad? Tenemos, como les digo, las rocas más, digamos, en el basamento de la placa acá en este sector tiene aproximadamente 23 millones de años. Los basaltos se generaron desde la dorsal del Pacífico, donde se generaron todos estos pequeños montes submarinos que vienen viajando conforme va moviéndose la placa y hasta la posición que tenemos el día de hoy, que es donde estamos. Bueno, este parece que ya nos va a funcionar mejor, vamos a ver.
Oh, I just saw 2.5. Come back.
Come back?
No, sorry, I'm talking to the temperature part, not you.
What are you seeing?
I'm seeing it's a higher temperature. It's jumping all over the place, but I'm gonna wait for you guys to.
We're stable.
You're locked?
Yeah.
Okay.
Vamos a ver si aumenta un poquito la temperatura.
Okay, now I'm stable.
Okay. Just give it a few minutes here.
It feels like it's catching on here, though.
Todos los muestreos de agua que se están realizando con distintos objetivos, por ejemplo, como les dije, estos se van a procesar por investigadores de Estados Unidos, pero también tenemos algunas muestras de agua con otros objetivos, por ejemplo, de medición de la acidez del fondo oceánico, de las aguas del fondo oceánico. Esto es analizado en la Universidad de Costa Rica por la doctora Celeste Sánchez del CIMAR. Entonces este tiene otros tipos de objetivos, ¿verdad? Esas son tipo de muestras de agua que se han tomado a lo largo de la expedición. Lo que son las muestras biológicas se analizan para conocer también el microbioma relacionado a los organismos. Esto generalmente también se lleva a cabo por investigadores de la Universidad de Costa Rica y investigadores internacionales. Y las muestras de roca van principalmente a la Escuela de Geología y también al instituto, ¿cómo se dice eso? Al observatorio de Estados Unidos. Además, contarles que lo que son las muestras que se toman biológicas van hacia la colección del Museo de Zoología de la Universidad de Costa Rica. Así que esto es una gran ventaja que tenemos en esta expedición, es que tenemos 10 científicos costarricenses a cargo y también el equipo de científicos internacionales. Entonces un equipo multidisciplinario, interdisciplinario, y también las muestras pues quedan en nuestro país, ¿verdad? Que esto ha sido tal vez una gran diferencia con respecto a otras expediciones, que las muestras se van para otros países y queda muy poco material o nulo en nuestro país.
Sure. Okay. You happy for me to move right now then, or you want to
I'm happy for you to move right now.
Ok, muy bien.
Yeah, we're kind of, that's about as much as I can do right there.
Okay.
Just because we're interfering with growth here.
Okay. So I also brought with me it's like a cut PVC cap with a T-handle on it.
Yeah.
And then a hose.
You can put a weight on that. Drop
And
the
it
hose.
has little dive weights on it.
Yeah.
So what I'm thinking I might do here is just take like 1 or 2 samples, but then maybe save effort for later.
Okay.
I can show it to you. And Jeff also brought one. So we would pull his out. The next time we're here, the plan is to recover that osmo, and then we could try putting that in. And then I could compare the two. Okay, so, and I'm just going to take a little bit here. It's definitely better, just so you know.
Okay. What are you seeing?
I mean, it's consistently above 1, whereas before it would like drop below 1.
Right.
Which is what I get in background seawater.
We're seeing about 2.05 on ours.
Yeah, I
So-
believe you. Every once in a while I see it too. I'm just trying to decide which pump speed gives me the more consistent temperature. wanna drop your probe in this hole in the bottom of the ocean. Alright, I'm gonna take a sample. I'm going to take bottle 1, starting.
Aquí ya iniciamos lo que es la toma de mediciones del agua. También ahora se dejó un osmosampler, ahora un poquito más temprano, para otro investigador, Jeffrey Witt, es para estudiar la composición hidrogeoquímica del agua principalmente. Y esto lo que se hace es una bombea agua, como digamos una muestra de agua cada día, como decir una gotita de agua, donde por ósmosis, por cambio de saturación, o sea, de salinidad en el tubito que trae, es como un tubito que va entonces registrando por día el contenido del agua por día, y así se va moviendo por ósmosis. Entonces en un sector va a haber sal, una solución saturada de sal, y el otro lado va a tener agua fresca. Y estos generalmente se dejan por bastante tiempo. Un registro tiene un largo de 300 metros y va registrando por día. Este se dejó para poderlo recuperar en algún momento que se vuelva por acá, pero van a estar escuchando este término porque algunos se dejaron en la expedición de junio y los estamos recogiendo pues en estos días, ¿verdad? Por acá, por este sector de El Dorado, y creo que recogimos uno ayer también en la pulpería. Dice que recoge 0,15 mililitros por día estos osmosampler. Algunos se dejaron desde el 2014. Estoy leyendo por acá.
Does this place have a name, or is it just Tengosed hole?
It was. There was a marker.
También algunas medidas interesantes que se realizan es el oxígeno disuelto, por ejemplo, que está atado a un muestreador o una toma de este tipo de medidas al sumergible Sebastian. Y estos datos se generan y se utilizan posteriormente por los científicos.
Oh, why I can't remember this cruise number.
También, como les dije, la temperatura.
I was getting confused. It's O2 or
Los registros de temperatura se dejan también algunos registros de temperatura por cierto tiempo, y después se recolectan unos recolectamos esta mañana, creo. Ayer sí recolectamos otro, y en el Dorado también recolectamos otro de estos medidores de temperatura que se dejan por meses. Lo que hace el registro durante cierto tiempo, y después se llevan y se analizan por los expertos. Además contarles que bueno, este nombre tan particular de Tengosed, bueno, nace de la expedición del 2013 donde estaban unos investigadores estadounidenses y con el poco español de secundaria que tenía, el doctor Andrew Fisher, pues acá se da una entrada de agua hacia la corteza, entonces es como decir tengo sed, pues, y de ahí nace el nombre, pues es el monte submarino más grande, que es donde se da la entrada de agua mayor para generar todo este sistema de flujos hidrotermales de baja temperatura. Y así hay distintas historias para cada uno de los montes submarinos que vemos por acá, o estas colinas. Estos nombres no son oficiales, por lo tanto ahora el equipo científico de costarricenses vamos a liderar lo que es la nomenclatura ya formal de esto. Se van a utilizar tal vez los nombres propuestos y algunos nuevos, ya veremos, pero en eso estamos trabajando para poder realizar toda la gestión que se debe llevar a cabo para realizar esta nomenclatura oficial y solicitar al Instituto Geográfico Nacional o a la Comisión de Nomenclatura este proceso, iniciar este proceso para tener montes ya en nuestro país pues conocidos y nombrados correctamente. Dependiendo las características del monte submarino, también así van a variar los nombres. Por ejemplo, podemos decirle si es más de 1000 metros, se puede llamar monte submarino, o si es, o dependiendo la forma que tiene. Hay unos que ustedes han escuchado, por ejemplo, el nombre de montículos, o a veces se escuchan otros nombres como colinas, lomas, pináculos. Todo esto va a variar dependiendo la forma y el origen inclusive de estas estructuras del fondo oceánico. Aquí estamos midiendo un poquito más de temperatura, 2.34, 2.30, por ahí bajó, ahí se está moviendo un poco. Posteriormente de la toma de aguas se realizarán tomas también de roca y más tarde se visitará o se realizarán transectos por lo que es el sitio que les comenté donde hay una acumulación de huevos de raya. que es un sitio bastante particular acá y bastante interesante. Estaremos tratando de ver si hay un poco de salida de aguas un poquito más calientes que la vez pasada no se observaron. También colectando algunos especímenes de octocorales que se requieren para estudios y algunos que otros, bueno, si se encuentra algún pulpo que acá, eso es uno de los datos, se ha observado, se observó creo que un pulpo la vez pasada, se colectó y pues se compara con los otros organismos que tenemos en los montes submarinos aledaños. Un saludo a mi esposo que está ahí conectado. Hola. Este no se observó en la columna de agua, uno de los, bueno, en el ascenso que realiza el robot, que eso no se transmite generalmente, entonces ahí es donde se observan algunos organismos de como este transparente, por ejemplo. Ok, para responderle a Valentín que está ahí, estas rocas son en la parte blanca, son los suces calcáreos formados principalmente de coccolithofóridos, foraminíferos, radiolarios y diatomeas. Estas rocas tienen aproximadamente bueno, acá no se han estudiado en detalle las edades, pero en general lo que se ha estudiado, que es en otro sitio, en otro de los montes submarinos, tiene unos 15 a 17 millones de años, y por encima de estos o intercalados también tenemos lo que son lutitas silíceas, que son las rocas negras que se ven en pantalla. Acá lo que estamos haciendo es tomando datos de temperatura que están saliendo por este conducto y tomando estos datos de agua.
Ready to biology?
I'm ready to smile.
Look at
How's that
cool.
right?
Look at my cool shirt.
Wow.
Isn't that a good one?
Oh my god, look
It's this Agui artist. I love it. Isn't it
cool.
cool?
That's cool. Yeah. Can you buy them online?
You can. Yeah.
It's
Great. Merch.
Who doesn't love some
Gooey
merch?
merch. Gooey's all about
Deep sea merch. Who doesn't love deep sea merch?
Yeah, Julia, she brought us all one. She did too?
You didn't get yours? Or in the package?
Like we all did, just you? Awkward. What's your stuff, Marjorie?
Huh? No. It's okay. It's not Isumi's fault. It's geology's fault. No, I'm gonna be done in 5 minutes and then it's off to you guys.
I think the transect will also go quickly on this dive. So it sounds like we're gonna have lots of time. I think we'll have lots of time to get up to the lots of spots that you want to explore but not. So the highlight reel went up so.
Yes, I'm
A cruise highlight reel or the
No, one of those.
the crazy big
Did you
jellyfish?
say exactly?
The 10-meter one?
Yeah.
Were you in the seat last night for the glass one? The glass octopus stuff?
No,
Okay.
I saw it in my cabin. And I was
Okay.
like, right when I got off shift, I was
That
like,
was insane, right?
yeah, it
beautiful.
was
I
insane.
expect that will be the next.
I'll send it.
It was gorgeous.
No, there should be no question. That should be a real show. Plus, the way you guys filmed was
Yeah,
off
it
the
was
chain.
epic.
Bueno, acá vemos ya un detalle mientras se toman las muestras, un detalle de briozoos. Esto que vemos por acá con estos brazos es un crinoideo, esponjas, estas esponjas hexactinélidas. Este es un detalle de algunos poliquetos, gusanos calcáreos, también octocorales por encima. Esa es la temperatura que se ha estado midiendo 2,35, por ahí fue lo que vi, un poquito más alto. Si esto es colonia de brezos, un detalle, y vean todos los organismos que viven atados a esta colonia.
All right, I'm stopping that sample.
Alright.
And we can very carefully put it away.
Alright.
Ahí observamos un detalle
Or Andy, remind me
de
to
la,
show you
de la
the
roca,
other
del
intake
colapso
that I
este,
have.
de esta estructura que es bastante interesante.
I think
Y
Jeff
aquí
has
es
one.
donde pues el interés de tomar estas medidas de temperatura y de agua.
What would you say the diameter of the crack is at that narrow part?
Oh, probably a meter.
Okay.
Okay.
Hi. How are you?
Okay.
Did I tell you about how they tried the people probe and got it around again?
Yeah.
So, you should ask her about the details. I don't know.
Shoot across. I think so forgiving about it. Just look there, I'll just grab it. Julie, are we going to do another sample of this very soon? Should I
Es
keep it
probable
there?
que se
No,
forme
okay.
por la disolución de los carbonatos. Entonces son con un material más suave, y los materiales de arriba que son un poquito más duros. Entonces al haber disolución en las partes blancas se genera un colapso. También puede ser por esta misma salida de flujo de calor que va generando esta disolución del carbonato y colapsa la estructura.
Yeah, it's
It's really down there.
Like if you see the crate, and you see the rope attached to it, it's all the way. Like we drop these and drop them on the crate. It's good. Just wondering, the RV
Is that?
Oh,
Just because the last first, some people put lots of things in there.
I see.
And then I hope it's a little clearer with the sample types, right?
I don't remember what the S.
So that this should be F. And then our SOI vegetation is super. Alright, you can power down the super.
Alright.
Yes! It's like, who's cooling me? Okay, where are we?
So we are just
Good. Good. Add marker
so we
or
are
whatever.
just
Yeah.
speaking about everything.
You've had a
very
busy shift.
complex.
Yeah.
So,
Good. Okay.
so they were, I don't know if they were continuing doing the measurements.
No, I think she's done.
She's done that.
Yeah. Right. So then, is this for you?
Let's collect an example somewhere in the museum. I think we
Ledge
need to-
sample is bio or rock. Rock.
Yes, we might want to open
We
up
have to collect
one on the bench and see if there's anything to see inside.
Yeah, we need to collect samples.
But that's ledge sample. You just pass by.
This is microbiome.
Yeah. Yeah.
Yeah. Just stuff it in there where we can find it as well. I think that weight is catching. Yeah. This is a good idea.
Okay. Then using this should be the black
The
top,
black, yeah,
and
the
then
white.
try to swoop the white.
Yes.
So are you gonna stay for that?
Yeah, we can do that now.
You want to do that
Because-
first
yeah,
while
I
you're
think
here?
So. Yeah,
Sure.
because I have to go to the for the interview.
We don't mind. We can do it now. Yeah.
Yeah.
So let's do it.
Okay, so I will leave you with Dr. Divestream. So thank you so much. We will continue sampling rocks, so stay tuned. Bueno, muchísimas gracias. Los dejo con la doctora Diva Amon, así que vamos a colectar rocas y manténganse conectados. Chao.
Morning, guys. Good morning, everybody. Buenos dias todos. We are here on the seafloor at just over 2,000 meters depth, 2 kilometers depth. My name is Diva Amon. I'm with an NGO that I co-founded in Trinidad and Tobago called Species, as well as the Benioff Ocean Science Lab at University of California, Santa Barbara. And I'm joined by the data logger today, Leo Chacon Monge from the University of Costa Rica, Universidad de Costa Rica. And today our RV pilots on my shift are Andy and Adam. And we've got Sophia in the corner as our media tech. So,
Hello.
during our shift, we are going to be collecting some samples. Whenever you're ready.
Where to?
Oh, great. Okay. So while Maria is in the room, we would like to collect a piece of this thick black crust.
I think we are far away, so we need
To move?
try to
Yeah.
just
So we
get
want to
a
collect a piece of this and then also try to scoop some of this. 2 different samples.
With the scoop samples, are going in the bio box?
We don't need to put it in the bio box. We can.
No, we have for it to go into BioBox 1A.
Yeah.
Yeah.
But okay with the both.
Can they both go in there? Is that okay?
I'm not sure.
No, I mean for like in terms of rock, your biology, can they both mix? Not biology.
No, for geology, yes.
Yes.
But if they want to, to
That's the only
to
thing-
study the microbiome, so
Do they?
sure.
Go ask Beth.
Yeah.
Yeah. Just ask whether both. She wants
Yeah.
both in BioBox 1A.
Okay.
Or do you want to take her?
Yeah.
I think it's the last time both the hands up. I came in and they
Thank you for
basically
coming
tried to
in.
put,
Oh my God, look, there are so many.
tried to put the wind like here.
Oh my God, I love it.
And then as you get closer, you kind of suck yourself in. And then it's that. So you can also do the one round, give it with the round up, and then just kind of
So we're just setting up to take some, first we're going to take some rock samples of this thick black crust you can see in front of us. And then we're going to try to scoop some of that white layer you can see
below. After that, we're planning to do some biology collections around here. So this sort of wispy animal you can see in the foreground, we think that's a new species of black coral. So we'll be collecting some more of those so that one of our collaborators on shore, Wendy Matamoros, she'll be describing those as part of her PhD from Universidad de Costa Rica. And then we're going to try to get some corals as well.
So for this one, it's for Gus.
Right.
So close to the hole, we need to take a sample, a rock sample.
Not of the black,
Yeah, we can have the black one.
of the ledge,
Yeah.
of this. Right, close to the
we
hole.
cannot go there. We have to go close to the hole, I think, so, to get this one for Gus. Because we cannot go to the ledge. Yeah.
Wait, hold
Yeah,
on.
close.
Tell me exactly what Gus wants, regardless of what the ROV
Yeah,
can do.
close to the conduit.
Okay.
Yes. So the conduit is in the close to the hole.
Right down
Yeah,
there.
exactly.
And then, so then you don't want a ledge sample.
We don't need that. We
Okay.
don't go there. Then we will try to use the scoop to collect
Right.
a light color sediment.
And that
stored
goes in
a
a
coral
coral quiver. Okay, so
Yeah.
this is a rock.
And we need to collect a Niskin bottle.
Yeah, that's fine.
Yeah.
Okay.
Change
My
plans.
apologies. So we are going to try to collect a small rock around
Somewhere around there.
this, yes, whole feature, basically. And then we're going to fire Niskin so we have an idea of the environment around it. Please.
Do you want me to fire the Niskin first before we kick up the sediment and put them on?
If you're absolutely positive we can get a rock here, sure.
I will get right first. We're gonna try because it's deceiving. It's quite a ways down there. Like when we put that milk right there, we can barely touch the milk.
Okay.
So I'll come down with the forearm and I'll just see, but I suspect we won't be able to reach those. But let's just try real quick.
Then don't fire the Niskin.
Okay,
Yeah,
so we'll
because
try
the
this.
Niskin has to go with the rock.
Right. Okay.
Thank you for asking all those things. Mm-hmm.
It could go with the first with the ones.
Okay.
First we can have the black one,
Mm-hmm.
and then here at the top of the curtain.
Yeah.
Because it's softer.
Yeah.
So we can put it.
Sure.
So we're gonna go pretty far in the building. It's text me. We'll be ready.
So this first geology sample we're taking is not actually from the ledge, as you can see. We're trying to get one closer to this big venting hole in front of us, and that's because this is going to go to Gus, who is going to try to look at the what microbes are living on that rock, and he wants it to be as close to this fluid outflow as possible.
That was literally on the stops. So easy.
I mean, yeah, what were you guys even talking about? So
So easy.
So that's going to go into BioBox 1A, please. A.
Hey.
Sorry. You're like, do we have a BioBox 1A? annoying about that animal that's floating away. But I'm gonna get a sample. Don't worry, talking to myself. As you do.
Grab it.
No!
Oh, really?
And it went down the hole as well. Okay, so we're gonna go again.
We're gonna grab
We're
another
gonna go
rock.
again.
What
Thanks,
did it-
Adam.
What did it hit?
It was on the edge.
Wow.
Grab another
That
rock.
was ridiculous. My apologies. We're not gonna grab it.
Yeah, a lot of rocks right there.
Mm. That's one thing there's not a shortage of.
See that one right there? You touched it.
Yeah.
Okay. It's just the shoulder joint is weird.
So while we're trying to collect this rock, thank you for joining us. We're here on the second leg of Octopus Odyssey, hashtag Octopus Odyssey if you're on social media. And this expedition has many different goals. The first is to try to characterize all of these new areas, or either unexplored areas or poorly explored areas of seafloor of Costa Rica in the Dorado area. So we're going to be visiting a number of different seamounts. Great, guys. A number of different seamounts to try to understand what the geology is like. Ooh, isopod. What the geology is like, and what life is there. And then also how it, not just what life is there, but how it differs between places and so on. We're also going to be studying, because these are really unique areas, there are some really unique areas where very low temperature fluid is seeping out of the seafloor. That has resulted in some pretty special places. If you joined us over the last 2 days, you would have seen that we were at octopus nurseries, so deep sea octopus nurseries, where there were hundreds to several octopus mothers all nursing their eggs, and a bunch of other chemosynthetic animals. And so we're trying to understand what are the linkages between the geology in the area, the fluid coming out of the seafloor, the microbes living within these environments, as well as the animals. Go, 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 go. Yeah, great. You want another one? No. Okay.
If you're gonna drop a rock, drop it down a hole, never to be seen.
100%. You know.
I would share with
Okay, so Niskin?
Yes, please. A Niskin would be great. That's for ducks.
I
Yeah,
can share with
microbial.
us this one.
Great. Microbial and geology.
When we go to the school, and that's it.
And if we can't reach all the way over, can we just turn to the left? Yeah.
Exactly.
It's just sitting.
I think it's the flags.
So we're going to be out here. Our last dive is going to be on the 13th of December. So you've got just under 2 weeks left with us exploring the Costa Rican deep sea. Okay, bottle one. Wait, bottle one fired.
Just the one.
Yeah. Yes, please. Thank you. Okay. What are you thinking in terms of biology? Well, so we'll scrape first. We'll do a scrape, and then we're thinking that those
Yeah, and there are some
Yeah, these.
umbellapatas. All these things that you see there
Mhm.
also are a priority. And there was a place just like looking to the other side.
Okay, like
Also
over
in
here.
the edge.
We are
I
going
think
to the
over
other
here
side,
there's a
yeah.
swiftia and some primnoids.
Okay, but we definitely want, before we move these
Yeah,
down around the hole.
I think they are everywhere.
Yeah, okay.
T.
Okay. We're gonna do your scoop first though. Yeah, sure.
Because it's the oldest rock that we have.
Ready?
Yeah.
Okay, so now we would like to try and scoop some of this white stuff. Given you can't reach all the way over here, maybe we could try to scoop down there. Do you think you could reach
Won't be able
that?
to scoop it down there.
What about if you turned and it like continues down here?
I think because I think we sampled this last time. I would suggest if you want the white stuff, we'll just go and land on our rock'em sock'em against that wall there.
On your what?
rock'em sock'em or the two rails.
Sure, okay.
And I think we can kind of do a little like.
Okay.
like this.
Yes,
And
that
that's
would be
going
great.
into Biobox 1B then?
That, no. So
Coral
that,
quiver.
exactly, it's going into coral quiver.
Okay.
Because it's going to be powdery.
Okay.
I don't know, hold on, before you move, we also want to collect some of this wispy stuff. So I don't know whether one will preclude the other.
Okay, if we're gonna, so do you want like a little snip of the coral there?
We actually would like to take a whole one if possible.
Sure.
Yeah.
Okay, so we'll do that with the starboard arm.
Sure.
So we'll have to just kind of hover over there and then land out, get set up, and go from there.
Sounds great. Thanks, guys. So when we visited Tengosed last time, it was it's a very diverse place with lots of sponges and corals. So just on top of the platform in the background, you can see this sort of little mini forest of corals and sponges. And so we're going to be transecting along that after we collect some samples, hey, to see what's around.
Yeah, so you're almost better off to.
And it's likely because of this thick crust you can see in front of us, that thick black layer above the white. That's likely very stable, and that has resulted in a stable attachment surface for many of these corals and sponges to attach to, rather than like rubble, for instance, so that they can grow and stay there for a very long time.
Something like that. We did this last time. We're just gonna have to find where we can purchase some rail.
Where do you want that sample?
Which one? The biology one?
Yeah.
If that can go into coral quiver too, please.
So I'll be working on the side of the. It's probably better to do some saves like we do right now. Sometimes, yeah. Let's do it. Yep.
Wonder how deep that hole goes. So also at this site, not only is there a lot of coral and sponges, but on our last expedition, the first part of this expedition, which took place in June, where we were out here for 3 weeks, we discovered a skate nursery. So skates are closely related to sharks and rays. And we came across this area where there were several hundred skate eggs all in one spot. And so we're wondering whether it could be a similar situation to what we're seeing with the octopus, where they're laying their eggs in an area where there is that slightly warmer fluid, potentially to use it to accelerate the development of the eggs, because the deep sea is so cold and many processes down here are so slow.
Diva,
Yes.
are you married to these ones here? What about some of these?
Yes,
rock
absolutely. Yep.
Okay, it's gotta be.
It looks like methane hydrate. I know it's not, obviously, but the white looks a little like methane hydrate. Have you seen like methane ice? I know it's not,
Yes,
but it
they
looks
do
like
it.
kind of like some methane ice has like pits.
Yeah, you know
Yeah.
that is like dilution, diluted, dissolved.
From what? That's what's causing it.
Usually it could be, I don't know, that has acidity in the ocean, I don't know, with carbonate. Maybe the same fluids that are actually wouldn't know exactly what is.
Because here would be above the carbonate compensation depth, right? That's usually like 4,000, 3,000, 4,000.
Yeah, we are beneath,
Yeah, above.
above.
Yeah.
So, but I'm talking it's less than the pH now in the bottom is low. So depending through time, you can do this kind of things.
Coolio.
And this is a rock, so it's different. And you have to create skeleton made of dissolved carbonate, for example, carbonate in a thermal.
Yeah.
That you really need like specific conditions
Right.
to get your body.
Yeah.
But those already are very old, so maybe it's a different thing. It's not the same we will say it's not the same carbonate that the animals are using today, compared to 50 million years ago.
Awesome.
Yeah.
Like,
You have a picture before you pull this out.
So,
You have a picture of the sample.
yes, please. Thank you. And if before we can we just flip on the lasers for a second as well? Thank you. Great.
Which one are you gonna go?
I mean, whatever you would like.
so you want the whole thing, or
Maybe this little like buddy boy over here, or I mean any. This is not one. This is many in like a tanglement, basically. So,
and right from the base?
if possible,
So
please.
I won't cut. I'll try to pluck it with the soft
Exactly.
nails.
Yeah.
Let me zoom in on the other. Let me get a zoom in and get a shot.
Sure.
Yeah, like here, there's like 3
Okay, so.
or more.
Well, that one right here
Yep.
comes straight down.
Is that your screenshot you had with that? Or?
Can you flick on the lasers again, please? Leah, we're taking some frame grabs, please.
They're little.
Yes, got you. Yeah, just hit a bunch of frame grabs. And so, are we able to zoom further just to get?
Yeah, we'll lose the lasers.
Great. Thanks, guys. Okay. Take some more screen grabs, please. Highlight frame grabs.
Pick a large diamond with bifurcation.
Pick a large piece with bifurcation.
Yeah.
Okay. So I mean, this one is bifurcated. This one is bifurcated. So, can we get one of those?
Yep.
Yeah. Great.
So is that one that branches into three then, and the base is the blackbird? Is that what you're saying?
No. So I think this.
Yeah.
It's hard to see. I think this is one. This
Oh.
is one. This is one. This is one. This is this. This might be one here.
Okay. So dealer's choice.
It's kind of hard to see. So I think if I were you, this one is clearly bifurcated. This one is clearly bifurcated. So I would go for one of those two, because she wants one that has the.
I
Hi.
think that's my pen.
Oh,
I'm
sorry.
gonna steal it. I left it in here. Yes.
Thanks.
This is
Oh
the-
no. Okay. So. Oh no, you're right. Okay, so you're totally right, Adam. So this is the base here. So
Yeah.
if we could cut.
Cut that little one off the right there?
Yeah.
Okay.
Like.
Where you want the
That
whole,
one.
You want the whole base or what?
Can you move it again? Can you just give it a little nudge? So I think if we, sorry, I'm giving you wrong instructions. If we could snip here, where that, do you see that black
It's
base?
It's gonna be closer.
You're on the edge. dude.
Just
Yeah, what I'll do, I'm gonna come up a bit.
because I'm worried it won't fit in a quiver if we get the whole
Right
thing.
in there a little bit. Just give it a little more. Or- Yep.
Yeah, they're quite big. You got frames of the one I was zoomed, right? Great. And we'll get some more just before we stow it.
Perfect. Happy, happy.
So you're saying, up this, the one behind that?
So, yes, if you can cut around there, that would be, because we
Okay, you
just
wanna-
definitely want to get the bifurcation.
Cut on the bottom there.
I mean, if we can cut down here, then that's even better, but we understand this is. So what we're collecting here, this is a black coral. These are known to live, well, not this particular species, but black corals, that group. Some of them have been aged in the deep sea, and they've had individual animals come in at over 4,200 years old, which is just a really good example of how things are much slower in the deep sea. Like, think about all that has happened in human history. Think about how many generations of people lived during that time, and this one animal would have been there through that. Timescales are just very, very different to what you and I are used to. That's great.
On the right. There's a six.
That's a black one.
Let's try to get it just straight. I just want to see.
Cleaning up the nurse. I just finished putting everything in my receipt, so my hair freezing. Alright, in that case.
I mean, whatever, you can see up there.
It's, I worry it's gonna take the whole thing.
I mean, if it is, let's go with it. As long as we can get it into coral quiver.
Yeah.
Go Adam, go. Go Adam, go. 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 Commit. Commit. Commit.
Nice.
I think you can bring it to me. That's that out.
Well, I come up there.
Amazing. And that can go into, yeah, coral quiver that you opened. Great. Wait, hold on. Oh, before we stow it, sorry guys. Can we just get a quick zoom?
Okay, you want me to pull it out and bring it over?
Or just, I mean, you don't have to bring it all the way over, but just a little bit out of the tube. Sorry. Thank you, Leo.
Head over.
Okay, just hit a bunch of frame grabs, Leo, and then we'll zoom a bit more in a second. You shouldn't need to type stuff. You just frame grabs.
Thank you.
Just a few, and then if we could zoom a bit, guys, please, just so we can get some. Oh yeah, beautiful. Great. Just some more blah blah blah. Great. Okay, thank you guys. We can stow. Appreciate.
Which container?
It's going into coral quiver. What? Two.
Thank you.
So after this, we are gonna try to get some of the white, scoop some of the white sediment, but so like that stuff, but from anywhere we can, and then and put that in a coral quiver, and then we're gonna do a few biology collections up on the ledge probably. There's not right here, just in this vicinity, and then we're gonna do the transects. Beautiful. So because we're going to try to scoop some of that white stuff, I don't know why they want to open one of the other coral clippers while you're here.
Okay, I'm just gonna throw a bit on this one.
Yeah.
Yeah, just a touch on this. This one there.
So while we're putting this coral quiver lid back on, we've got an amazing team of scientists on board. Many, about half, hailing from Costa Rica itself, from 2 universities there. We've also got folks joining from the US, from Trinidad and Tobago. Where am I thinking about? Anywhere else? And then we've also got shoreside collaborators. Several people who sailed on the first leg are now on shore, following along as well. And one of the really wonderful things about this cruise is that all of these biology samples, like this black coral that we've just stowed, are going to be staying in Costa Rica at the museum there, which is for any of you that potentially, well, it's often not what happens during deep sea cruises. Samples are collected and then they leave the country potentially. So this is really exciting that they're going to remain in country and allow a whole new generation of Costa Rican scientists to work on them. Great. Let's try to get some white sediment. Please. Sure. So we're just going to do an RV change.
There's a ground floor on such a sampler jar, so I just turned it off.
RV watch changed on an RV change. That would be weird.
The index wing motor's working.
What's that?
The index wing motor's working.
We haven't done suction yet. So,
The index wing motor's working.
And so for a less economically developed country, Costa Rica has actually had quite a bit of deep sea work done, which is great over the years. There have been a number of incredible deep sea environments discovered within Costa Rican waters. Hi.
Hola.
So we would like to try and collect some white sediment. There was below at some point. There's there. But essentially scoop it and stow it into a coral quiver. Not sure what's possible.
Okay. How far away are they?
There was some below earlier, but I think we're now on top of it. Potentially.
Yeah, but just the stuff, though, right?
Yeah, exactly.
Okay.
So given while the RV guys are setting up to do this next collection, given that there have been these incredible places found in Costa Rica's waters like methane seeps that are home to Kiwa pura vida, the dancing yeti crab, if you don't know what I'm talking about, Google it, as well as some seamounts with incredible coral and sponge and other animal communities living on them more south from here, as well as here, these areas of low temperature venting that act as, we think, nurseries for several species. And given Costa Rica's long and proactive history of environmental stewardship and conservation, both on land and in sea, and at sea, one of the key priorities for this expedition is going to be all good? Okay. So as I was saying, because Costa Rica has this long and proactive history of environmental stewardship and conservation both on land and in sea, one of the key hopes for the data that we are collecting as part of this two-leg expedition is to use that to inform new areas potentially of conservation in Costa Rica's waters. Excitingly, Costa Rica is going to be co-hosting the United Nations Ocean Conference. This is a really important moment from an ocean policy perspective globally. And they're going to be hosting that in 2025 with France. Next year, they're going to be having a pre-United Nations Ocean Conference in San Jose in Costa Rica. So these are really key moments that we're hoping to act on and really leverage. So we're just setting up to take a sample of some of this. You may have noticed the seafloor has different layers here, and we're going to try to collect some of the second layer from the seafloor surface, that white sort of calcareous stuff that we're seeing.
Transect. Yeah, I think we're just going down and we come over to the line.
line is going.
Yeah, we just sit behind it.
Yeah.
I can't see anything around here.
Yeah. Good.
The only unknown is, exactly what time that line actually comes over this position.
Yeah.
I mean, at least once it comes through, well, we'll actually hop over it, so then we'll be able to keep just the values on it.
Okay.
And hopefully, we'll clear off faster than keep up with it. See how it goes?
All right, let's see if I can find
And
a
is
spot again.
there-
In this decimal, that's-
Or any spot where we can see this white
Yeah,
exposed
I'm
stuff.
just waiting for he gets this out of here, I can-
We'll do the discussions.
No, I was just thinking.
Yeah, the problem is, so the boat itself is 11 miles away on the south of us, so we've got at least 11 miles in that direction.
Oh,
I think the other boat, the line to the north of us, they're like 25 miles. So this one's similar.
Yeah. And so we want corals, black corals. They're here. Okay.
Maria, are you directing the sediment sampling? Yeah. Just behind us. Yep, exactly. Yeah. It's maybe a little bit further south, because we're, the waypoint, we landed just to the port side of the waypoint. So it's like right in the rim of that crater where we were.
Okay.
So if you come back to that.
Even if it's the same species.
Even if it's the same species, in fact, that's better.
Better,
So I
okay.
get some replicants.
Okay.
But I barely had enough tissue last night. I had to change the experiment. Okay, thanks.
Yeah.
Appreciate
You
it.
hear that? So when we landed at waypoint 1.
Mm-hmm.
So after,
Slow it down
yeah,
there.
so if we come back to waypoint 1,
When we're done. Yeah.
we will see them on
Okay. And what do you say them?
I think they were Primnoids.
Okay.
And super.
Great.
If I'm not wrong.
Okay. Oh yeah, look at all that white stuff. I mean, you're gonna be taking over in 15 minutes, so yeah. Please. So while we're setting up to sample this white layer you can see here, Maria Isabel Sandoval from Universidad de Costa Rica is going to explain how this very unique geology is formed.
You want this in the corner?
Yes, please.
Yes, please.
Then you can set it down.
If we can scoop, we'd prefer
Yeah, we gotta open the corner
on.
first.
Yeah. Okay, while it's yeah.
Okay, this is calcareous ooze that is formed from the accumulation of pelagic organisms like plankton, like coccolithophores, foraminifera, planktonic organisms that live in the column water. So they live in the shallow water. Usually we call those organisms like marine snow. So through time they were accumulating in the ocean bottom. So these rocks that we are sampling here, usually they form during the Miocene. We don't know exactly which million years of the Miocene, but probably 15, 17 million years ago. So we have very old rocks here. This whitish color is made of foraminifera, coccolithophores. Those organisms are principally made of carbonate, and also we have diatoms. When we do a smear slice of this rock, we can take a look of that under the microscope and see all these small microorganisms, like also radiolarians or silicoflagellates. And we try to do is to get the species, to determine the species, and then to get an age using these species that got extinct through time.
They will go back to they north off Booker too. They did that closest to us. What? 3.4.
Do you want to get zooms before we scoop, or do you not mind?
Zooms up the mud.
No, we don't need, don't worry. Just scoop away. Yep.
Eosin? What is Miocene? Miocene is a H with M.
IOCENE.
Miocene. It's a geological name for an it's an epoch. Yeah, we call Miocene. It's like that.
Oh, I know. Yeah.
Yeah, you know.
That person does. It's a pretty robust scoop. A very robust
Yeah.
scoop. Oh yeah.
Just like you scoop it, just go and get some scoop and then you can get to rotate your hands as much as possible. Like a dump truck, not like full scoop.
Well, like, yeah, as much as we
Yeah.
can get, and then we're just gonna
Yeah.
dump it into the coral cover. Yep.
Please.
Play in the sandbox.
Everyone's set.
It's like play in a sandbox.
Nice good chunks coming out there.
You want just the crust or you want,
Yeah, we don't want this down here, right?
Yeah.
We want this,
Yeah.
where is that?
yeah. Basically what we're getting right now is great.
Exactly.
Put it bigger and then come up and rotate counterclockwise. Counterclockwise, clockwise. Yeah. Good. Just go back to the straight. Go.
great.
That's great.
Oh, yeah.
That's great.
And then that's just so. I think that's just so.
That's great.
Because we only are going to get transects up by skateboard now, we should definitely like try to look at the try to look at the imagery to like because we're going to be short on time, so we're not like
Are you going to make another sample?
No, so since we're handing over, if you're ready, so we did all of this. Super wasn't working, as you know. This is cancelled. There's long lines. So it's basically just from now until 10:30, collect everything you can. Yeah,
Okay,
and go back to the small.
I will go back to waypoint 1 and start
Put
collecting
down
stuff.
there. Yeah, sounds great. Okay, so we're just getting ready to do a science watch change. I'm going to hand over to Beatriz Naranjo from Universidad de Costa Rica, and she's going to take you through a bunch of biology collections. Thanks, Bea. Thanks, guys. I'll be right behind you. Don't worry.
Yeah, it's
No, I know, but all the whole area is done for
great. Thank you, Diva.
Thank you, Bea. I'm right here. Next to you.
Good morning, everyone. My name is Beatriz Naranjo. I'm part of the Costa Rican team on board the Falkor 2 vessel. We are exploring the Tengosed Seamount around 2,000 meters depth in front of the coast of Costa Rica, about 200 kilometers away from the coast. This was an interesting place. We found this hole and we also found in last June a skate nursery close to this area that we are aiming to explore later in the afternoon. We are taking some samples for geology purposes. And now we will start to collect some samples, some coral samples for our taxonomists here on board Falkor 2. I'll be speaking primarily in English, and let us know if you have any questions. We are constantly checking the YouTube and Facebook chats.
I don't know if Randy told you, she said if we can, replicates.
Oh yeah, she told me. Yeah. Buenos días, bienvenidos y bienvenidas al monte submarino Tengosed, un lugar bastante interesante que exploramos en nuestra primera parte de la expedición en junio. Estamos trabajando en este marcador X que habíamos colocado pasado junio, donde encontramos este agujero donde fluyen fluidos hidrotermales. Ahorita estamos haciendo algunas recolectas de rocas para microbiología y para geología, así como estos carbonatos que estamos colocando en nuestros contenedores. Mi nombre es Beatriz Naranjo, formo parte del equipo científico de la Universidad de Costa Rica a bordo del Falkor 2. Por la siguiente media hora aproximadamente vamos a estar recolectando muestras biológicas, principalmente corales, que serán analizadas por el equipo de taxónomos y taxónomas a bordo, así como para realizar algunos experimentos. Todo este sedimento que ven caer ha sido acumulado por millones de años a partir de partículas suspendidas desde la superficie que poco a poco van cayendo, entre ellas muchos organismos que viven en el plancton y que cuando mueren comienzan a caer lentamente hasta depositarse en el mar profundo y con el tiempo se van compactando. Estos sedimentos son muy interesantes porque podemos encontrar muchos fósiles de microorganismos y esto nos ayuda a datar. We want to come back to waypoint 1. We saw some corals in that area, so if we come back to that point, we will see them and make some periodic collections for the half.
Okay. Is that enough of this stuff in there?
¿Es suficiente, María?
Sí, if we can collect the rest of the rock on the sides.
That one that's sitting on the side?
Yeah, please.
We can try to get that one. It's
Yeah,
pretty
okay.
crumbly, but once we put the scoop away, we'll know if we can get
Okay.
it. Okay, let's go get the scoop away. The scoop, we're gonna put it away.
I think we also have only half an hour left.
Yeah.
We should try to move on.
Yeah. ¿Qué es lo que necesita la ropa? La ropa.
Sí, en la pata.
Ya, ya. Estamos trabajando con el ROV Sebastian para aquellos que no están familiarizados con nuestros muestreos. Como ven, es un robot submarino conectado a un cable, conectado con el barco a través de un cable en todo momento, y a través de este cable podemos observar en vivo las imágenes desde el fondo oceánico mientras nos encontramos en la sala de control del Falkor 2.
You wanna grow in a loose crab?
It's small, but these are coming out.
Okay, you want another? Okay.
I mean, you're right
Yeah,
here.
I mean,
so
if it's here, we can try.
yeah, this
way they don't have to set up again. It should save some time. So
Yeah.
we should be able to just take the MRI.
Yeah, I think, yeah.
You're putting way up there to the left? Yeah, I'll have to move.
It's right here.
Yeah, but this
Yeah.
arm, I don't know if that
Okay.
arm can reach.
Okay.
Which is not a problem. I can make it.
Okay. Yeah, that would be better than move away. La tecnología a bordo de este barco es bastante impresionante. Está constantemente siendo actualizada. Hay incluso algunos sistemas que usamos a bordo son diferentes a los de junio. Siempre hay algunas mejoras que constantemente el equipo científico de Schmidt Ocean Institute está haciendo a sus equipos. Así que es bastante impresionante y sin toda esta tecnología no tendríamos acceso al honor de poder ver nuestro mar profundo. Vamos a intentar recolectar algunos segmentos de este pus calcáreo y posteriormente vamos a estar recolectando algunos corales. Recuerden que pueden dejar sus comentarios o preguntas en el chat de YouTube y Facebook.
That's not gonna make it. Is it okay if we just put the lid on? Is it okay if we just put the lid on? I don't think that. No.
they will.
Maybe it'll make it up to transit.
Yeah, let's collect the scars.
Yeah, it's okay.
But the lid.
Thanks.
Sorry.
Estas investigaciones forman parte de una serie de trabajos que hemos estado realizando en el país con el apoyo de equipos científicos internacionales. Gran parte de lo que hemos estudiado como equipo costarricense ha sido alrededor de la isla del Coco, gracias a un submarino turístico, y poco a poco hemos estado haciendo contactos y teniendo el apoyo de equipos científicos, principalmente de Estados Unidos, para poder hacer alianzas que nos permitan tener acceso a barcos de investigación como el que estamos a bordo. Han sido muchos años de estudio. Seguimos desconociendo gran parte de la diversidad de ambientes y biodiversidad que tenemos allá abajo, pero poco a poco hemos ido explorando y conociendo mejor todos estos lugares que nos interesa mucho conservar. Un ejemplo de eso es los criaderos de pulpos que encontramos en junio y que visitamos en los dos buceos anteriores, así como el criadero de rayas de profundidad que tenemos en la cima del monte Tengosed que estamos explorando hoy. Thank you, J-Rod.
Okay, so you want something up here, right?
Yeah. This one, right, Randy?
Yeah. Yeah.
Uh,
exactly. But they're very small. So
Okay.
They're very small.
Yeah.
if you see a bigger one in sight, great. Otherwise, I think we should just
Or move, just
go to the other spot.
Or move if you know. Yeah, okay.
You
If
wanna
you know
move?
if you know there's more, then we'll move.
Yeah, there's more. Okay.
Picking up and going?
Thanks, Steve. I didn't know.
Do you prefer to look for bigger
I will
ones?
look.
Okay. So we should move away to waypoint 1.
Is it going to bother you if I stand here?
No, not at all.
I can see better.
More than welcome.
Because I can look at the bottom cam too.
Oh.
Thanks.
I have next to me Dr. Randy Rothan. She's doing some experiments with the corals. Those are primnoids as well,
I
no?
think so, yeah.
Yeah. Yeah, those are big ones.
Yeah.
And they're so sweet. Yeah,
Yeah.
I think this is a good spot for our collections.
Okay,
All
so
these,
which one?
all
The two fans?
this one.
You want both of those?
Yeah. Yeah, right. The other
Yeah.
one as well. It's good
Yeah.
for your experiments.
Replicates
Yeah.
are good.
Okay. But let's get the white ones first. Then I'm gonna ask for that.
Thank you.
Do you want to explain your experiments?
Sure. You don't have to move. I can stay right behind you.
Okay.
What time is our cutoff?
So
10:30.
10:30.
What time is it right now?
10:11.
All right, I'm gonna swap out with you.
Mhm.
That's very good.
So as I was saying, I have next to me Dr. Randy Rothan from Boston University, and she's doing some coral experiments that she will explain right now.
Hi everyone. Hola, good morning, buenos dias, good evening, good afternoon, wherever you are in the world. I am here with Bea and Odaleska, and we are going to set up to get some corals. Many different things are happening here. It's very exciting. Oda is identifying them and trying to work out what species we have here, and because there are many species in the deep sea that are unknown, and Oda is a world expert who's helping to characterize the taxonomy and diversity of corals here. And I am an ecologist and a physiologist, and I'm interested in looking at how these corals respond to different stimuli and different challenges. And so we are working them up in the lab, and so we don't need a lot of individuals of many different species, but I need a lot of tissue for one, because I will run experiments even when the ROV is in the water, again and again and again. Every 6 hours I have a new experiment going. So I'm really excited about the opportunity to get some tissue so that even when it seems like we're offline, I can keep the work going. So this is a really exciting opportunity. I can work with shallow water corals in the lab at home, but I can't work with deep sea corals anywhere or any other time than when I'm at sea. So here, yep, that's it.
How many do you want?
How big is it?
Can you put the
It's big?
laser sound, please?
Then let's take, what do you need?
Maybe this part from here,
Yeah, good.
Good.
from here maybe,
Okay.
here.
Mhm.
Yeah, and then we'll take the other one next to it, if they're quick.
Yeah. Okay.
I don't want to interrupt.
So,
It's fine, get right now the time to interrupt.
Thinking about what we're doing this afternoon.
okay. Can I los láseres, no?
How much are you gonna need? How much are you gonna need?
You need 3 branches, like.
No, I need more than that. I barely had enough last night. You need 3 branches.
Don't look at, yeah, if you wanna change any of your time.
Why do you?
No,
Yeah.
the thing is that I need a big piece too.
Okay, so then let's get let's do
You want
more.
multiple
What is
pieces?
this size?
De
It
centímetros.
has to be one big piece, not
Hubo
multiple.
como 20. ¿Quieren que agarremos
Yeah.
todos?
And we really need to get some, so let's just get
You want multiple
one
pieces?
big sample, I think,
Exactly.
of the thing, and then we move on to get other samples.
But, I mean, you want it in a coral quiver though, right?
Yeah.
Yeah.
One big
Well,
piece doesn't
no,
work.
we can put it anywhere that's free because we're
Yeah.
coming up.
Then, yeah, if you
So
want the
let's
whole
so
thing, I
just
give
take
you the
a
whole thing.
big punch
Take
and
it.
put it in a butter box.
Whole thing, part of
Maybe
it?
you can take the whole thing.
Yeah, because I need a lot of sample.
Yeah.
Alright, y'all got all the photos y'all need?
Okay.
Happy with photos?
¿Tiene la foto, no?
See?
Yes.
Alright, and what bio box can I put this in?
2 is free, 3A is free, 3B is free. 2 is the massive one.
Okay, but you don't care? 'cause
We don't care because we're
Yeah.
following the camera. You can look up with a sip, that'd be fantastic. This one's not crunchy, right? It's baby?
right.
It's the one to my right that's a little crunchy, or
Correct.
the bubble gum?
Yeah,
Yeah.
the one to the right is a corallid. The one that you're working on is a Primnoid. It's flexible. I think it's a corallid. It's hard to tell.
Seems like
So this is a chryso?
What?
It's a chryso? No,
No, it's a corallid, I think,
coral.
or a hemicorallid.
But does Oda want the corallid?
I don't know.
Yeah.
Sure.
y'all aren't changing your mind right
No,
now.
no, we're
right?
no,
No, we're not changing our mind.
No, no, no. It's okay.
I think we need to double check what Oda wants after this.
Yeah. It's, she said the Chrysogorgid, but apparently it's not a Chrysogorgid.
Watch out.
Let's wait till she comes back.
Go ahead, Bridge. Watch out, please.
I'll go find her.
Camera back.
RV bridge.
Go ahead, Bridge. Understood.
Thank you.
Open where the biolabs is. Please. The biolabs too.
Tengo aquí a mi lado a la doctora Randy Rohan de Boston University y ella estaba explicando que es ecofisióloga, trabaja con corales y está realizando algunos experimentos a bordo donde tiene unas pequeñas cámaras que le permiten
Yeah. Two.
que le permiten hacer mediciones de respiración y esto le permite ponerlos bajo diversas condiciones y entender cómo los corales responden.
Those biolabs too. Nice and easy. Nice and fast.
If you're within reach of the other Primnoid, and while we're waiting
Am I
to hear
going-
what
Am I going
Oda
for the
wants,
pink one, or am I going for?
I would get the other white
Where,
one.
where he was.
Get the other. Until we know what Oda wants, let's get the other white one.
Doesn't have to be
Camera out.
something here.
Oh, here's Oda.
Is that it?
Ese es un coral, ¿no? El que está a la par, se
Am I
puede
going
decir.
for the pink one next?
Es un paraborgia.
¿Lo
tal
quieres?
vez. No, era otro primero
Otro.
que había por ahí.
Ah, okay. So,
There is one with
We
like
have
with
13
three
minutes, so
branches
if we wanna
that
move,
were.
let's move.
What are we
Ahí
looking
está
for?
el que quería
This one?
that one. Can you focus that one?
Which one?
The small one.
The Swiftia?
The Swiftia? The red one?
And
No, it's white in the
no,
middle.
the red one
White
is
Swiftia?
no that's
Oh,
white.
you want the red or the white?
No, let
Okay,
me
wait.
see
no,
that.
they want this one,
Let's
right?
just let
The Primnoid.
Oda-
Let me see that.
Yeah. Can you zoom
You
in,
just
please?
have time for one.
Oh, no, it's not.
That's not it's
Okay,
too,
if
too
I
small.
have time just for one, mejor el amarillo que está acá.
But you might have time for two, so think about that.
Okay,
This one.
these ones.
Yeah,
This
one.
one.
of This one. Yeah,
Okay.
this
Which one?
yeah.
The yellow one.
Closer to us?
Yeah,
Bring the
exactly.
starboard rail in, please.
Yes.
Yeah.
Actually, no,
It could
you're
be
fine.
the half.
You're fine, I can get there. So you got your images you need?
Can you put the lasers again? No. Voy a tomar sueño.
Sí, con el láser.
Se llama esto,
Can you zoom in a little bit more?
Oda, what's the second
Okay.
one you would want?
No, the behind is a sepia. I want the one that is in front.
Yeah, the yellow. If you had a second coral in this area, what else would you want?
Thank you.
Maybe the Primnoid that is right here, or maybe the black coral. ¿Ya reconectaron el número?
No.
Digo, el número no
El
es
esquizopatio, sí.
Yeah, that one.
Alright, I need you to bring the starboard rail in, nice and
Eso es no.
You know, it's tiny.
Ahora ya.
Can you collect all the things, please? All the animal? El esquizopatio no, el umbelopatio no.
That's good.
Pero me di que llegar a la parte.
Sí, pero solo tenemos tiempo para una más porque hay que subir una vez.
Sí, ok.
Entonces, ¿cuál prefieren?
Un pedazo para ver.
Okay.
Just one or two?
Pero ese es un pedazo.
There's two right there.
Ah, there's two.
Just one.
You don't want two?
Just one?
Just one.
You don't want both pieces?
Entonces,
También tenemos a bordo a la doctora Dalis Cabri de la Universidad de Costa Rica. Ella es especialista mundial en octocorales, que es el grupo que estamos recolectando en este momento.
¿Marco los dos?
Es más fácil. Okay.
Okay. It's because I didn't see another one around, so.
It's easier to.
Yeah.
Okay,
Now it's
take
much
the
harder.
both, take the both things. So,
It's easier.
Okay, I think
Do
we got it.
you want one? Because I can get one now.
Okay.
Okay,
Let
give
the-
one.
yeah.
Yeah.
Okay, both of them, I'm sorry.
Nice.
Thank you. Wow.
Call me, please.
Como ven, la habilidad de los pilotos es impresionante. Muchas horas de práctica. Siempre tienen pilotos en entrenamiento.
Hold on.
Can you do the closer?
Can you close it?
Yes, please. Before the. Mira nomás esos Swift, así agarro los pedazos de ese.
Y el que está al alcance también es un Swift, ¿no? Ese.
Will you click your autofocus button?
Que está en la estrella.
Great. Perfect.
Pero es que creo que ese no alcanza el brazo.
Yes.
Entonces tenemos que buscar uno que esté cerca.
Este que está aquí nomás, no está cerca.
Ese. Voy a preguntarle.
This is the number one.
Porque el que tenemos
Ese es
cerca.
en Quiver, Quiver One, I think.
Yeah.
Ah, este que está abajo es igual.
Mhm.
All right.
No lo quiere.
Sí, que
Nothing
agarre
else
ese,
going in
que
that
esté más
quiver, close
fácil.
it, or are you gonna stack corals?
Another coral and
In the same quiver, or they need to be separate?
No,
if it's a
separate, please.
please.
What time is it?
We have 10 minutes.
You have to go out now?
Yeah. Veo, este es igual.
Right.
Este
Take
está
a
más
photo.
Sí,
cerca.
ese mejor, más fácil.
Then the pink one and we're ready.
The pink one that's right here?
Yeah.
Okay. And that's going in the quiver as well, or the vial
Eh,
box?
no,
the-
el quiver, en el quiver.
todo está vacío.
Ah, okay.
If it's fastest and
Vial box is faster, but
yeah,
Well, it is faster for you.
You want a piece, right?
so
Just tell them. So they know.
which people?
This one.
This one right
This
here.
one that is
You have
just
good
here.
images?
yeah.
That one here.
The whole thing?
No,
or-
no,
or-
half
Okay.
thing.
Get your images if you can.
Yes,
Yeah.
good images first.
Can you put the lasers on? There are unos frames de porfis.
Can you see the lasers?
Yeah.
Yeah,
You
okay.
have it? Okay. We're ready.
This is a real brittle one, right?
Sorry?
It's brittle?
Yeah, let's try with the brittle here for the
Yeah, it's
start.
No,
Is that-
the coral itself is brittle, like it
Oh,
or is it a little bit?
no,
Does it
not
break
exactly.
easy?
It's kind of no. You have to cut it because
Okay.
it is flexible. It's kind of flexible.
if
not
we can
that
get a
brittle.
brittle star, that would be amazing.
You
Yeah,
want
piece
brittle?
with the brittle stars.
There's a whole bunch of brittle stars. Just one branch that has a brittle star?
Yeah, please.
Yeah, pretty good.
But if you can take more from I don't know. you
Right,
can
right, right, right.
go
Point
down.
again, point again, point again.
Like from there.
You want from there? Okay.
¿Tiene un nombre para este? Igual otro para acá.
Swift, yeah.
You're gonna get this big branching branch? Well, that's
O expect allá. Lástima que no tiene los pólipos afuera, mae.
So in right here?
Yes,
Yes,
it could be there.
amazing.
Yeah. Y tiene todos los zoantios.
Este coral que estamos viendo es del género Swiftia. Es un octocoral, un coral blando que tiene 8 tentáculos en sus pólipos que usan para alimentarse, y los animales amarillos que vemos son otro tipo de nidarios, del mismo grupo de los corales, pero en otro orden.
I got the whole thing.
Okay.
Okay, take it. No problem.
Thanks.
There are more around.
Los animales que ven enrollados en el coral son estrellas quebradizas, y a bordo tenemos a Leonardo Chacón, un estudiante de la Universidad de Costa Rica, especialista en este grupo. La biodiversidad de echinodermos en aguas profundas es bastante impresionante. Tenemos muchísimas especies, pero muy pocas de ellas están representadas en el Museo de Zoología, que es la institución de la Universidad de Costa Rica, el repositorio oficial nacional para muestras biológicas, donde estos animales van a seguir siendo estudiados. Todas estas recolectas las hacemos con permisos de las autoridades nacionales. Y ahora forman parte de nuestro patrimonio en museos. Thank you.
Five minutes left. You can still time to one more if you want.
Okay, maybe for Wendy. Right?
Yeah.
Yeah, yeah. If we can get one of these black corals here that have like 3 leaves, that would be amazing. And we can put them in BB3B if it's quicker.
I just opened it.
Oh, okay, amazing. Okay.
I got both options for you.
All right.
You're fine. Go get
Okay.
four.
That would be for BB3.
Yes.
Yeah. Any of these. The one that's maybe this one. Here.
That one?
Yeah, that one.
There, the image.
Yeah, this laser sound.
Maybe 2 branches. O ella quiere la parte de arriba.
Todo. Eso es importante.
Biobots, biobots, three,
No,
deep.
Quiver 3.
Either that or Biobox, doesn't matter to me.
Okay.
No, that was there.
This one.
Yeah.
We got the image?
La anterior, sí.
So we got copies.
Tiene las
Pass.
imágenes, ¿no?
Sí.
No las imágenes.
Okay, go with it.
Yeah.
This guy, right?
La parte de
Yeah,
abajo.
please.
Sorry.
Biobox 3A.
Ah.
3A.
This is Biobox
Okay,
30.
yeah, let's wait a minute just for the images.
Sorry. Did we please ask for that?
Yeah, please.
Wait, forget. So don't do that yet. Just take some images now. Frame grab. Just snap a bunch.
Y'all gonna get me in trouble.
Right. And now do your sample.
Okay, ready?
Yeah. This morning did not go as we expected.
Yes.
Thank you, Jared.
Alright, so good
It's
to go
okay.
Biobox, or do you want that in the quiver?
If you already opened the Quiver, let's do the Quiver.
The Biobox would be quicker.
Okay, so Biobox.
Okay,
Uh,
Biobox.
Leo, this is going to 3B.
Yeah, that would be quicker. Alright, just open it up.
Just put it on.
Sorry, guys.
No worries.
I thought you were gonna get a test up.
No.
Y'all need a close-up? Sorry. Got any close-up before it does it? I think you got that done.
Yeah, let's do the close-up. You have it? Ready?
Yeah. Happy?
Okay. Yeah, thank you.
So,
Biobots, three.
BB3B. BB3-B. Este que acabamos de recolectar es un coral negro. Tenemos una colega en continente que trabaja con este grupo, también estudiante de la Universidad de Costa Rica, Wendolyn Matamoros.
alright, so.
Saludo a Wendy si nos está viendo.
Done.
La extrañamos por acá.
What's that? Leave the bigger open? Yeah, I'm fine.
Thank you guys.
That was the last scramble, but well done, guys. That was amazing. Are we done or are we out of time?
Muchas gracias. Vamos a traer estas muestras que necesitamos en este momento al barco y esperamos estar con ustedes de regreso en unas horas. Así que vamos a dejar el fondo, vamos a cortar la transmisión en unos minutos y nos veremos más adelante. So we're leaving the bottom now. We hope to come back to Tengosed, to the skate nursery area in the afternoon, so we hope we can do that. Right now we will take the sub out of the water and we will come back in a few hours. So thank you for watching us.
And here we go, another glass octopus! I just wanted to come on live because we were all very excited about this, so hope you're all enjoying the ascent. This is actually, this is my first glass octopus ever for me when I've been in this room and not at home or in my cabin.
I'm starting to think that who did? I'm starting to think that these things are not as rare as people want to make them out to be, because I see them all the time.
Yeah.
Go ahead and stop the
So
winch.
pretty.
Stop the winch. Suction coming on.
People are filing into the room.
All right, go ahead.
The heat flow probe, yes. Tighten those bolts up.
It's on the rocks.
Andrew said he found. It's his unit.
Say hi to Julia.
Good afternoon, morning, evening, and good night to everyone, wherever you are out there. My name is John, formerly technician on board RV Falkor 2. We are live streaming from ROV Sebastian right now, and as some of you might be aware, we are in the middle of a recovery. We just have to do some operational moves, and we will be back with part 2 at the Tengosed location for more exciting Octopus Odyssey imagery. So we should be back in about an hour and a half or so. So stay tuned, and we'll see you when we return.